MATD 1534, we're busy with Unit 12, Symmetry. Last time we did a couple of examples here, and this morning we're going to look at some more examples. Okay, so just remember, when we test for symmetry, we do the x-axis, we do the y-axis, we do the origin. It doesn't matter in which in which order you do them. You can start with which one you want to do first. It's not a problem as long as you do all of them, meaning x-axis, y-axis, origin. And please write what you're going to do. Like for the x-axis, you're going to swap the y for negative y. For the y-axis, you're going to swap x for negative x. For the origin, you're going to do both. And then remember, we swap, and then we must make sure that we get the original equation back for the symmetry to uphold. All right, so let us do another example or two this morning about the symmetry. Okay. Right, so I had a request for an exponential graph, so let's do one. So let's say we have f of x. Let's say it's 2 times 3 to the x. Okay, let's say it's 2 times 3 to the x. All right, and we need to test for symmetry. The question is, we must test this function for symmetry. Okay, right. So we're going to do the x-axis. We're going to do the y-axis. And we're going to do the origin. All right, so for the x-axis, we swap y for negative y. For the y-axis, we swap x for negative x. And for the origin, we do both. X for negative x, y for negative y. Okay, remember I told you that symmetry in the origin is also the same as doing 180 degrees turn. So you can turn your graph through 180 degrees and then decide whether it's going to give you the same picture back. If it does, it is symmetrical. Right, so let us do now the x-axis. So we're going to swap y for negative y. Okay. And then we see we get y is minus 2 times 3 to the x. Maybe we can talk just a little here. So here we get negative the original graph back. Now when we, in mathematics, we're going to do it, it's still coming, this work is still coming, but I'm starting to introduce it now. So in mathematics, when we get the negative of the original back, we say the function is an odd function. Okay. All right, but we will get to that. But for now, it is not symmetrical because we do not get the same equation back. So for today's lesson and still on symmetry now, this is still not symmetrical. So this graph e to the x is not symmetrical in the x-axis, but we know that because we know that the exponential 2 to the x graph is like that. And when we're going to throw it over the x-axis, it's going to do that. And that doesn't give the same picture back. It gives a different picture. So therefore, it is not symmetrical. Okay. Right. So if you have the graphs in the back of your mind, and you know what the picture, the graph is going to look like, then you can actually see in your mind's eye if it's going to be symmetrical or not. Excuse me. Okay, so let us look now for the x-axis. For the x-axis, we just swap x for negative x. So this is 2 to the 2 times 3 to the negative x. Now remember, if we have 3 to the negative x, you can stop here, but I just want to show you this. So you can say this is now a third to the x. You see, because a third is 3 to the minus 1. Okay, and we have also, we know that if we have a fraction, okay, let me just do it here. So again, that's the original graph. Now we're throwing it over the x-axis. So now it becomes that graph coming down. So clear for us that there can't be any symmetry here because you don't get the original graph back. So no, not symmetrical. Right, and now if you go look at the origin, we do both. So we say negative y is 2 times 3 to the negative x. So y is going to be minus 2 times 3 to the negative x, which we can, again, you can stop there once again, but you can write it then as minus 2 a third to the x. I prefer to write it like that because then I know that it's a third that is playing the role here. 3 to the negative x doesn't give me that same feeling as a third to the x. The point is it's also not symmetrical. So this graph has no symmetry. And remember we had a question last time about will one work or something. So here you can clearly see we need to take each of them, as a separate sum. We cannot, well, there can be patterns formed, but I mean, if we test for symmetry, rather, do what you're supposed to do here, like we're doing here, and make 100% sure if there will be symmetry or not. Even if you can see what the graph should look like, you must still do it algebraically because this is a question. This question is asked algebraically, so you guys will have to do it like we are doing it here. But as you can see, it's really not difficult. This is what you must do. What I've done here will give you full marks. So please make sure that you just do everything that you should do here. Let us do another function or another example. Okay, then I'll give time for questions. So let us also do f of x. Oh, we can say y. Let us do y is a half x to the 3. Okay, so and we need to test for symmetry. And remember now, at the moment, our test for symmetry is for the x-axis. For the y-axis, and once again, you do not, y-axis and the origin, you do not need to do it in this specific order. As long as you know when you do the x-axis, you're going to swap y for negative y. You're going to swap x for negative x. And you're going to swap x for negative x and y for negative y. Okay, and then we can just do, so negative y is a half x to the 3. So y is negative a half x to the 3. Going to the x-axis, we find y is a half negative x to the 3. And again, we get the negative, the original, telling us this graph is odd. That's on the y-axis, we look at that, but it's still coming. And then here we have negative y. Oh yeah, remember please once again to use brackets here. Please, please. Don't do that without using brackets. Okay, so minus y is a half. Once again, use brackets here. Please don't fall into a habit of not using brackets because you're going to get confused with the negative here. So first, I count the negatives, of course. So I will count there's 3 and another one there's 4, so the answer should be positive. Okay, here's 3 negatives, so the answer should be negative. Here's 1 negative, so the answer should be negative. So here 3 and 1 is 4. So I know already it's going to give me a positive answer. So it's going to give me a half x to the 3. Yay! And that is the original graph. So this is symmetrical. Okay, this is not symmetrical. And remember, we mean there symmetrical in the origin. We mean here not symmetrical in the y-axis, or with respect to the y-axis, as the book is saying. Doesn't matter. You can say as long as we understand what you mean. And so here it's also not symmetrical in the x-axis. Please remember to answer the question, because the question was test for symmetry, so we need to tell them where it is symmetrical and where it is not symmetrical. Let us just do another one here. Let me do it somewhere in the yellow. Say now we had y is square root x, because that is also a mother graph that we must know. Now, if we look at the y-axis, so we're still doing x-axis, y-axis, origin. Okay, let's start with the x-axis, sorry. Start with the x-axis. I'm not going to write everything now here, but remember you're going to, if you have to do it, you will need to write the x-axis, y-axis, origin, and what you're going to do. But we've got it at the top here. So we know for the x-axis, we're going to swap y for negative y. So we're going to have negative y is square root x. So y will be negative square root x. Okay, for the y-axis, we're going to swap x for negative x. And we're going to find this. Be careful here. We're going to do domain and range. That's the next part we're going to do now. Some people will now say this is undefined. But you must be careful because x can be less than 0 here. So we must just see what our domain is. Okay, so if x is less than or equal to 0, this will still be defined. Here we will have x is greater than or equal to 0, of course. So it's going to depend on the domain. But this function will exist if x is less than 0. But remember now, this is not going to be symmetrical because we do not get the original back. And this is also not going to be symmetrical because we do not get this original back. Okay, and when we do the origin, we swap both. So negative y is square root negative x. So y is negative square root negative x. Oops, and please, we cannot, those two negatives we cannot group together. And I often see that somebody with your mic, please. Because please, just your mic. Okay, so y is negative square root negative x. And then remember I said just now that those two negatives we cannot group together. Please be very careful. We've often asked this specific one in the exam, and then you do get people doing that. Be very careful. Remember, you cannot take a negative into a square or take it out there. So the point is, again, this x will be less than 0 here for it to exist. But for now, at the moment, it is not symmetrical. It's not symmetrical. Right, so this is then all about testing for symmetry.